Welcome to Lesson 3, the Calc-Based Physics series. This is Mega, bringing you acceleration, the next natural step after learning velocity and speed. The two terms you will learn in this lesson is average acceleration and instantaneous acceleration. The formulas for those, the average acceleration is right here. Remember, this kind of gives you your clue that this is a vector quantity. Just saying. Well, anyway, that's the change in the velocity over the change in time. Note that the velocity, the average velocity, was the change in the displacement over the change in time. So now we're doing the change in velocity over the change in time, and this is acceleration. And we're going to talk about acceleration, the difference between average and instant acceleration. And soon we will begin a few videos on different problems that you may encounter in a calc-based physics class regarding velocity, speed, and acceleration. So, enjoy. So, what is acceleration? Consider you're driving to work, and it's a straight line. You're starting off at 0 miles per hour. You start your car, you hit the pedal to accelerate, which you've always said accelerate, and you accelerate up to 100 miles per hour. What you're saying is your velocity, or your rate of speed, or whatever you may want to call it in this instance, is changing. There's a change in your velocity over some period of time. When that occurs, you're said to be accelerating. So, acceleration is merely this change in velocity over this change in time. Consider, if you're in space and you throw a ball, and let's just say that ball is at a constant velocity of 10 meters a second, and you throw it, and it travels some distance, and it's still going 10 meters a second. It's constant. The velocity is staying the same. If you look here and you plug that change in velocity, well, if the final velocity is 10 meters a second and the initial velocity is 10 meters a second, then your change in velocity is 0 meters a second, and 0 over anything is 0, so there is no acceleration. So, acceleration only occurs when there is a change in velocity over a change in time. Before moving on to average acceleration and instantaneous acceleration, there's a couple areas in which a lot of students usually have difficulties with. That's understanding negative acceleration and deceleration. Keep in mind, negative acceleration does not mean necessarily that an object is slowing down. So if the acceleration is negative and the velocity is negative, the object is actually speeding up. Just remember, velocity is a vector quantity. So when velocity is negative, it's only implying a direction. Acceleration is derived from velocity. It comes from velocity. It is actually a change in velocity over a change in time. So acceleration is also a vector quantity. So if the acceleration is negative and the velocity is negative, then that means the object's going this way, and it's going increasing and increasing in that direction. Now, negative acceleration can mean the object is slowing down, but that occurs when your acceleration is negative and your velocity is positive, or your velocity is negative and your acceleration is positive. For instance, let's say you have an object going to the right, which is a positive distance or direction. Let's say the acceleration is negative. Well, now you have a force, or in a sense, something pushing back at it. So the object is slowing down in this case. And the same is true as if you have the object going to the left, and in this case the acceleration was positive. The object is slowing down. So, when you see something that says, when you see a negative acceleration, don't automatically assume that that means the object is slowing down. Take a look at the rest of the problem. Try to find out about the velocity or anything like that so you can get a clearer picture on what is actually happening to that object. Don't assume that the object is slowing down just because it has a negative acceleration. This is very important. Deceleration. It has this like idea around it of something that's slowing down, but it'll confuse the definition that we have given for negative acceleration, so we won't be using this term. This term is not going to be used in this course. Only negative acceleration. Keep in mind though, negative direction, or keep in mind, if the acceleration of the object is negative and the velocity is negative, the object is actually speeding up. So negative acceleration does not necessarily imply negative or an object slowing down. What are the units of acceleration? We'll do this part quickly. This is pretty easy to understand. Velocity deals with, you know, some length over some time interval. Length could be in meters, inches, feet, doesn't really matter. Time interval could be in seconds, hours, nanoseconds, doesn't really matter, but it's a change in a length over a change in time. Acceleration is equal to the change in velocity over a change in time, and velocity is this, so acceleration is L over t, which is the same as L over t squared. If that's confusing, look at L over t over t. Let's go ahead and get rid of this denominator. So we'll multiply by 1 over t to the top and bottom. These cancel, and we end up we multiply across, and we get L over t squared. So, units you might see for some velocity of an object, it might say an object is going 10 meters a second. You're talking about acceleration, it'll be something like 10 meters a second squared. So this, when you see this form of a unit, you should know automatically you're talking about acceleration. And if you see this form, you should know automatically you're talking about velocity, or perhaps speed. Alright, so that's the end of lesson 3, dealing with acceleration. Subscribe, rate, and comment. To all my subscribers, leave a comment in the box concerning a video or a topic you would like to learn about, and I'll post a video on that topic as soon as I can. In the next few videos, we'll be just solving some problems dealing with velocity, acceleration, speed, and all that good stuff to apply what we've learned in the last 3 lessons. Thanks for watching. Alright, this is really similar to the difference between average velocity and instantaneous velocity. And if you know calculus, it should be fairly simple, which you should know calculus for the series. So anyway, let's get right into it. The formula in blue is referring to the average acceleration, and it's just your final velocity minus your initial velocity over your final time minus your initial time. And this, keep in mind, this is really analogous to a slope. Your change in y's over your change in x. It's really nothing different than that. Now, instantaneous, once again, is simply the same exact thing, but with the limit applied to it, to make something instant, pretty much. So this has a time interval, and this is just assuming that that time interval, so you have, you know, you start off and you're like, okay, well, here's going to be my t final, here's my t initial, which would make this my, let's say this is the velocity, right, and this would be time. This would be your final velocity, and this would be your initial velocity. So if you want to find the slope of the line going through these points, that would simply be your change in velocity over your change in time. Now, as this change in time gets closer, because right now we have a secant line, as we get closer and closer, let's say this is the final time, and then this one, as we get closer and closer, as this interval becomes 0, or extremely close to 0, we achieve the tangent line going right through it, which would be representing that instant acceleration. So, in order to go from average acceleration to instant acceleration, all you do is apply the limit. Simple, right? So, before moving on, let's make a quick point about this as well. So your instantaneous acceleration, we say, is the derivative of your instantaneous velocity over, or with respect to time. So it's the derivative of the velocity, instantaneous velocity with respect to time. Well, Vt, what is the instantaneous velocity? Well, isn't that the derivative of your displacement over time? So if that's the case, we can substitute that in right here, and what we get is this. Well, what is that? That's a second derivative operation on top of the first. So acceleration, if you're still working with the first equation, let's say, you take the derivative of, your first equation, you get the which deals with displacement and time, and you take the derivative of that, you get the instantaneous velocity. Well, if you take a second derivative, you get the instantaneous speed. How we write that in notation is, you could put like a d with a 2x over d2 dt squared. Alright, so this is basically saying that if we know something about the position and time of an object, the first derivative will give us the instantaneous velocity. The second derivative will give us the instantaneous acceleration. If this is a little confusing, don't worry, there will be quite a few videos coming out shortly on different word problems that you will encounter in a calc-based physics class, and it should become more and more obvious as time goes on. So, yep. Alright, so that's the end of Lesson 3, dealing with acceleration. Subscribe, rate, and comment. To all my subscribers, leave a comment in the box concerning a video or a topic you would like to learn about, and I'll post a video on that topic as soon as I can. In the next few videos, we'll be just solving some problems dealing with velocity, acceleration, speed, and all that good stuff to apply what we've learned in the last 3 lessons. Thanks for watching.